All right, guys. So today is Monday the 11th for A Day or Tuesday the 12th for B Day. This is the video that I need you guys to watch to kind of get an idea of how to do some more advanced stuff with naming. We're not going to do an ed puzzle with this, okay? So I have our assignments for today listed right here. So we've got a warm up, and I'll just talk about the warm up in class, so I'm not going to talk about it in the video. This video is for after the warm up, okay? And I'm not going to do the warm up in the video. This is our video lesson that we're doing right now. And then when we're done with this, guys, I have some practice that we're going to do together. So this is done together. It's not for a grade. It's kind of to get you an idea of how to answer the questions. And then I need you guys to do this one on your own. And I'll be available during class for questions. Okay? So we're talking about Unit 5 on naming compounds. We've so far talked about how to go from the formula to the name for simple binary compounds, meaning that there's only two elements. So now we're going to work backwards. We're going to write the formula from the name. So if I said, here's sodium chloride, what is his formula? His formula is NaCl. All right, and I'll show you how to do that. And then how to name ionic compounds with polyatomic ions. So we'll look at polyatomic ions today. Keep in mind, next Monday we'll have a quiz over what we're covered in Unit 5. We're not done with Unit 5 as of next Monday, but I want to take a quiz kind of halfway and kind of see where everybody's at, and then we'll move on with a couple new things then. All right. Let's see. All right, so here's the warm-up. So I'll give you the link to the list of polyatomic ions. I'll actually give you two different lists. This one is one of them, and then I have another one that I'll show you. And basically what I'm going to do is ask you to look at that list, starting at the top of the list, fill in the blank for the names of the formulas for the questions that follow. So here's the 19 questions or so. There's 20 questions in the warm-up. I know it's kind of long, but I wanted you guys to see how to use this chart. So the name is on the left, written out, and then the formula is on the right. This one actually has two formulas, and that's okay. Either formula is fine. Usually we'll use this one. And so here's the formulas. And so basically what I need you to do is to look for the first one, acetate. So write the formula for acetate. Well, the formula is right here. You just look at this chart. Next one, what's the name of this guy, this ion? Well, let's go back. It's right here. See how it's paired? So these are paired up. And just go down that list, okay? And then turn in the warm-up, and you're good. A polyatomic ion is an ion that has more than one element in it. So I know it sounds like a complicated thing, but it's really not. All right, an example of a polyatomic ion is the cyanide molecule, or the cyanide ion. And it has a carbon and a nitrogen, so it's two atoms, but together they have a charge. So that's one carbon atom attached to a nitrogen atom, and then the whole thing just has a -1 charge. So that's a polyatomic ion. And they get more complicated. Notice that this one has 3 atoms. It's got carbon, hydrogen, and oxygen. Okay, and let me draw a picture of that one. So we've got C, H3COO. Oh, there we go. So that's that molecule. And the whole thing has a -1 charge. All right. And actually, I'll show you guys how to draw all these drawings. This is the Lewis diagram. This one's a little advanced. This might not be something that you guys would draw in this class. That's okay. All right, let's keep moving. So here's our warm-up. So let's practice the most common ion. So nitrate. All right, so that's the name of an ion. It's a polyatomic ion. So I'm going to go back to my chart. I'm going to look at nitrate. Notice that I see it right here. And it's an NO3 with a -1 charge. And if we just put minus, we mean -1. We just don't put the 1. Same thing here, NH4 with a plus. that means +1. We just don't put the 1. Now, if it's a 2, like carbonate, we're going to put 2 minus. A lot of times we just write them backwards. So that just means that the whole thing has a -2 charge. We just write it backwards, so don't let that confuse you. All right? So let's write these formulas. So nitrate is NO3 with a -1. It's a very common ion. Sulfate is a SO4 with a 2 minus. Phosphate is a PO4 with a 3 minus. Carbonate, and I'm going to have to label this one, is CO3 with a -2. And then ammonium is an NH4 with a +1. And there's a lot more ions, but these are kind of the common ones. And I found these by looking at that chart. Okay. All I'm doing is looking on the chart, getting the formula from the name as it's listed. That's it. All right. Let's look at the opposite. This is the nitrate ion. We'll see him a lot. The sulfate ion, phosphate, carbonate, and then ammonium. Okay, so most of these are 8s. Now notice that there is a difference between the nitrate molecule, which is NO3 -2, and the nitrite molecule. And the nitride ion. And I'll show you guys a video with this, a little bit more detail. Here is nitrate. Here's nitrite. 8 and I are 2 different endings for most polyatomic ions. IDE is usually saved for monoatomic, meaning it's just one element. So in this case, just nitrogen. So if it's "ide," it usually just means one element. Now there are 2 exceptions that I should mention right now. Hydroxide is OH minus. It ends in "ide," but it has 2 elements. And then cyanide. It's another one that has 2 elements, but it ends in IDE. But other than those 2, every other one, if it has 8 or ite, it's more than 2 elements. And then if it has IDE, that usually means that it's 1 element. All right, so let's write that down. IDE equals only 2 elements. Oh, actually 1 element. 8 or ite. I guess it could be also us or ic if it ends in these prefixes. Or suffixes, I guess. If it ends in any of those, then it means usually it has polyatomic. So then you'll have to look at your polyatomic list and see what the formula or what the name is. All right, moving on. How do we write formulas from the names? So this is for simple binary ionic compounds, meaning it's only got 2 elements. Here's how we can write the formula for a compound. We read the name to determine what 2 elements are in the compound. We determine the symbol and charge of each element from the periodic table, which I showed you guys how to do that, and we'll review that. Write the symbol and charge of each element side by side. Add a plus or minus ions until it is charge balanced. So that means equal and opposite charge for the total charge. The total positive must be equal to the total negative. If that's the case, it cancels out and it makes 0. It has to cancel out and make 0. Or you could cross the charges, which I'll show you how to do that. Check that the total charge of the compound is equal to 0, equal and opposite charge again. Okay, so first let's review the periodic table. How do we determine the charge of the ions? So if it's in group 1 here, hydrogen down, that's +1. This is beryllium down, this is +2. This is boron here, it's a +3. Carbon is usually a plus or -4. Nitrogen's a -3, oxygen's a -2, fluorine is -1, and then helium, neon, these are 0. So those are your charges. We have not yet discussed the charges of the transition metals, and that's because they vary. And so we'll do those next. Maybe later this week we'll do transition metal compounds. Like iron nitrate. It's got iron, which is not in one of the groups that we've discussed. It's not here. These are called representative groups. It's not in any of those groups. It's in this area, or maybe it's at the bottom of the periodic table, those 2 rows. Maybe it's in one of those 2 rows. And so we'll talk about how to deal with them at that point. But here's our charges. Group 1 plus 1. Group 2 plus 2. Group 3, which is boron right here. Boron family. Boron, aluminum, these are plus 3 charges. Carbon, silicon, these are plus 4. Nitrogen, phosphorus, these are minus 3. Nitrogen, phosphorus, minus 3. Oxygen, sulfur, these are minus 2. Fluorine, chlorine, bromine, iodine, those are all minus 1. And then noble gases here at the end, group 8, no charges. Okay. All right, so let's write some formulas. So sodium chloride. So I look on the periodic table, I find the element sodium. Its symbol is Na. It is in group 1, so it has a plus 1 charge. I'll even write the 1 in there. We don't have to. Actually, most of the time we don't, so it'll look like that. But I'll put it in there just so it's clear. And then chlorine has a symbol Cl, and it's a minus 1. All right, so I write the name, the symbol, and the charge for each of these elements side by side. I check and see if they would cancel each other out. If I had 2 teams and they each had a score of 1, this guy has a score, so his current score is 1. He just happens to be positive. This is the positive team. And then this guy over here, his score is 1. Nobody's winning, right? They're tied, and that's what we want. We don't want a winner. We want a draw. Okay, we want a game where there's no winner. And so we just put these two together and say, okay, there's our formula. Because when it's balanced, that's the formula. We only need 1 sodium and 1 chlorine to come together. Their charges will cancel each other out. That's why there's no charges when we write the formula. We just write the symbols for the 2 elements. Okay, and what we'll do here is if the charges do not balance, then maybe I could put a 2 there, or maybe I could put a 3 there, and I could change the subscripts. The subscripts are the little numbers. Okay, and then keep in mind that for the formula, the elements always start with a capital letter, and then if they need to have another letter, it'll be lowercase. Notice that sodium is capital N, little a. Chlorine is capital C, little l. Oxygen is just O. Potassium is just K. Sulfur is just S. So you kind of have to get used to looking at elements and the periodic table for this. So sodium chloride, again, is NaCl, which you guys probably know that, right? You guys know sodium chloride. That's your table salt on your french fries. All right, next one, magnesium chloride. Magnesium is in group 2 on the periodic table, and so it has a plus 2. Chlorine still has a minus 1. Okay, let me show you 2 ways to solve this one. One of them, the first way, is by reasoning. Okay, what I'm going to do here is I'm going to say, okay, they both need to be the same charge. Magnesium is a plus 2. Chlorine is a minus 1. So what I could do to make these equal, the easiest thing that I could do is add another chlorine ion. Right? Because now I got plus 2 over here, minus 2 here. Plus 2, minus 2. Equal and opposite charge. And then I write the formula. How many magnesiums do I have? Mg, we could just write 1. So that one's good. And then how many chlorines we got? We got 1 and 2. This is 2. And now, so this is our formula. Now we don't write the 1, okay? Because if I write Mg in a formula for a compound, I don't need to put 1. If I write Mg, it means 1. So the formula, final answer, is MgCl2. That's it. So that's reasoning, okay? Let me show you another way to do this one, and it's called crossing the charges. It's not really necessary for this problem specifically, but we'll try it. So crossing the charges. So what I do is I write Mg plus 2, and then I write Cl minus 1. What I do is I take the letters, not the charges, and I write them, and I leave a little space here. Okay. And what I'm going to do is I'm going to grab the 2 on magnesium. He is going to cross to the chlorine, and he's going to go right there. I take the 1, he goes down to the magnesium. So they change. Now the charges are gone. The plus and minus are gone. It's just Mg1 Cl2, and again, remember when we write our final answer, we get rid of the 1. So our final answer is MgCl2. And notice we get the same answer. So crossing the charges is where you take the charge, but just the number on the metal, and it goes to the nonmetal. You take the 1 here, and it goes down here to the magnesium. And then that tells you the ratio between those two elements in that compound. And crossing the charges becomes a little bit more useful when it's not that clear. Like if you have a 2 and a 3. And so it'll become more useful in the next examples. Aluminum chloride. Aluminum is in group 3, so he's a +3. Chlorine is a -1. Okay, so if I do this by reasoning, I have +3 on the left side. I have a -1 on the right side. So what I could do is I could add 2 more chlorines. That'll give me a total of -3, and I have +3, so they would cancel out. And then just write the formula, AlCl3. Okay, they have to be equal and opposite. Or if you guys like the cross method, let me show you that. If I do the cross trick shortcut, I write these symbols down here. I leave a little space for where I'm going to put some numbers. The 3 goes down into the chlorine. The 1 goes down into the aluminum. So I got Al1Cl3 or AlCl3. That's our answer. Marvelous. Okay, that's the cross trick. Again, you remove the charges. You just want those little numbers, those little subscripts. All right, let's keep going. Calcium phosphide. Calcium is in group 2, so it is a +2. Phosphorus is in the nitrogen family, so it's a -3. This one, it's extremely useful to do the cross trick, okay? Because you have 2 different numbers, and it's like if I add, these are evens, right? So if I add more of these, right, that gives me +6. Let's just add 2 of them actually. So that's +4. Well, now if I add another one of these, all right, I had -3. If I add another one, now I got -6. It's going to be tricky to get these balanced, right? And so for some of these, I might just try the cross trick first. So for this one, I'm going to write the symbol for both, leaving a space to write those numbers. The 2 will come down to him, to the phosphorus, and the 3 on the phosphorus will come down to the calcium. So that's our formula, Ca3, because we had a 3 here. And so I'm going to write Ca3P2. Now let's check those charges. Calcium, if I have 3 calciums, each a +2, that gives me a total +6. Let's look at the phosphorus. I got 2 phosphorus, each is a -3. Ooh, a -6. Look at that, equal and opposite charge. So you can do it by reasoning, by adding one of the other ions until you get the equal and opposite charge, or you can do the cross trick. Keep in mind, though, when we write the formula for this guy right here, Ca3P2, we want to make sure that the formula represents the smallest ratio between the elements. Okay, I'm going to explain what I mean in a second. Okay, so let's say I had sodium chloride, and I wanted to write the formula for it. Well, NaCl is actually correct. That's one possible answer. Na2Cl2 is also correct, because if you had 2 sodiums and 2 chlorines, it's also equal and opposite charge, right? But if I take this Na2Cl2, if I have a 2-to-2 ratio between the sodium and the chlorine, and I divide them both by 2, what we get is a simpler formula, NaCl. The simplest ratio between those two elements is 1 to 1. because I can divide both of those subscripts by the 2. And so you want to make sure that you write the simplest formula. Okay, not just any formula that would work, right? You could also put Na3Cl3. Well, that would, if you divide both by 3, then you get NaCl. So you get the same formula when you divide them out. So make sure that you have the simplest formula. Okay. One second. My wife is needing something, but I'm going to tell her it's going to have to wait. Okay. We just did this one. This was Ca3P2. All right. Now let's look at naming compounds with polyatomic ions in them. Okay, so I'm gonna put a box around the polyatomic ions in here. So this is nitrate here, sulfate, phosphate. These are both ions in this one. That's an ion there, that's an ion there. And I know that because I looked at my polyatomic list that we talked about at the beginning. So let's look at this first one. This is sodium right there in A. So I'm just gonna write sodium. Okay. Now if I look at my list, I see that that is called nitrate. So I'm gonna write sodium nitrate. Okay. When you write the name for these compounds, you do not include the numbers, right? I just write their names. This is sodium here, so I wrote sodium. This guy's name is nitrate, I write nitrate. Notice that the name does not tell you how many is in the formula. Okay. Next one, this is calcium here. I'll do this in black. Calcium, Ca. And then this is sulfate. If you look at the chart, so calcium sulfate is his name. Okay. Next one, I'll do it in black again. Al is aluminum. And these actually shouldn't be capitalized. I don't know why, but I have a habit of capitalizing them. But they're not capitalized. They're not nouns. So, and then PO4, that's phosphate. So that guy would be aluminum phosphate. All right, the next one is this guy that I just circled is ammonium. If I look on my chart, that's the symbol for ammonium. So I write ammonium. And then this is nitrite. If I look at my chart. So ammonium nitrite would be that guy. This is strontium, which is a group 2 metal. And this is perchlorate. And I actually just realized that this is not correct. The formula for this should be SR2ClO4. Wait, actually, no. What is it? SRClO4 2. That should be the correct formula because strontium is a +2, ClO4 is a -1. So I'm going to need 2 of those. That's a -1, -1, that's -2. I need +2, so it's got an equal and opposite charge. So strontium perchlorate. But notice that even if we have 2 of those, let me rewrite this so y'all can see it. Let me do it in red. So if I write SRClO4 2, its name is still strontium perchlorate. The 2 is not indicated in the name, and that's very important to understand. Later, when we do molecules, we will indicate the number, but not at this point. Okay. Last one. This is magnesium. So I write the name of magnesium. I write magnesium. And then this is permanganate. So I write its name. Okay, so that's how we name polyatomic ion compounds. I write the metal first, or the ion. In this case, ammonium was one of them. Ammonium is actually the only positively charged ion. All the other ones are negative. So I write the name of the metal, and then I write the name of the polyatomic ion. I do not change the end to IDE like we did before. It's very important to keep in mind. Okay. Let's see. We did these. All right, so let's try some. Example 1, sodium nitrate. Sodium is Na +1. excuse me, if I look up nitrate, it's NO3 minus 1. Well, remember that when you're done, just look at it and say, is it equal and opposite charge? Yes, it is. So just put them together, NaNO3. There's our formula. Sodium nitrate. That's a very common one. All right, next one, calcium sulfate. Calcium is a +2. Sulfate is a -2. Equal and opposite charge, right? So put them together. Calcium sulfate. Don't assume it's just going to be 1-to-1, okay? This is a very common mistake. Students will look at the thing. They'll say, I'm just going to put one of each, put them together. Did you check it? A lot of times they're not going to be 1-to-1. Maybe we need to put a 2 there or a 3 or whatever. All right, so there's our answer there. That's the same one. Okay. Ammonium chloride. Ammonium is a NH4 with the +1, and chlorine or chloride is a -1. Same charge, just put them together. Again, don't assume that it's 1-to-1 unless you've checked it. You have to check the charges of these guys. Ammonium is a +1 because the formula for ammonium is this right here, which means +1, right? Because that little plus. It's got one positive, one charge. And then chlorine here is in group 7, and so he's a -1, just like his buddies. Fluorine, chlorine, bromine, iodine, all -1 all the time. Okay. And most of the time. Can't say all the time. All right, calcium perchlorate. Calcium is a +2. Perchlorate is a ClO4 with a -1. All right, so ask yourself, are these equal and opposite? Not this time. How can we bring up the negative? We got a +2 on the left in the middle. We need a -2 on the right. So let's add another one. And so we're going to need 2 of them. So Ca, I just need 1, so I'm just going to put Ca. Remember, we're not going to put the 1, but we do need to put perchlorate in parentheses and then put a 2 out there. Okay, so that would be the formula for this guy. Let me rewrite this a little nicer. This is hard to read. So we have CaClO4 2. So that is the formula for this guy. We're going to need 2 of the perchlorates because we need a -2 charge to balance with the +2 charge. So that's the formula for calcium perchlorate. Wunderbar, which is German for wonderful. All right, we did that one. Ammonium nitrate. Ammonium is NH4 with the +1. Nitrate is NO3 with the -1. That's a +1, that's a -1. Equal and opposite charge. We're good to go. Just put them together. Ammonium nitrate used in explosives. Awesome. Okay. Ammonium hydrogen carbonate. Ammonium is that. Hydrogen carbonate is actually one molecule. It's HCO3, the -1. And it actually used to have another name known as bicarbonate, which is what I kind of learned it as, and they changed it on me. So either of those names is okay for that molecule, hydrogen carbonate or bicarbonate. And sometimes you'll see that if you look up stuff online, you'll see an old name of compounds that we don't use anymore. You know, the science and the naming kind of changes here and there, and that's okay. So we have a +1 and a -1, so we put them together. There's our formula. We put them together, making sure that we didn't change any of the numbers or the letters. We don't want to change what they are. We're just going to put them together. But make sure that you take away the charges. The charges are gone because they cancel out. Awesome. That's it, guys. Let's look at another worksheet that I want to do with you guys. Let me find it. It's actually going to be online. So let's see. Chemistry. All right, bear with me, guys. So it's going to be in my drafts. Ionic practice. Why is it not opening? There we go. Here we go. So let's do this one real quick together. This is very similar to the one that you guys are going to get. The one that I'm going to do with you guys is on binary ionic compounds, which we've covered pretty well. The one that you guys are going to do on your own is the polyatomic one. Okay? So let's look at this one. All right, so I'm going to put my name up here. Mr. E. And then it does say to cross them out, so I'm not sure how to do it, how you guys would do this. I guess this part, don't worry about it. It says, from the following list, cross out compounds that are not ionic compounds and circle the ones that are ionic compounds. Ionic compounds are the ones with the metal and a non-metal. So you guys can skip this part because I'm not sure how you would draw an X on these. So I'm going to circle the ones that are ionic. One second. Come on, work with me. All right, so we're going to circle that one. We're going to cross that one off. Circle that one. Circle that one. Cross that one. So I'm circling the ones that have a metal and a non-metal. Those are ionic. I am crossing off the other ones that have two nonmetals. Those are not ionic. You cannot make an ionic compound with two nonmetals because you need a metal and a nonmetal to make a positive and a negative. Okay. All right, and then here's some examples. Let's look at these examples. Formulas and name examples for ionic compounds. Potassium iodide is Ki. Sodium sulfide is Na2S. Remember the 2 is for balancing. BaO is barium oxide. NaCl is sodium chloride. Hey, we know that one. Zinc fluoride is ZnF2. BeCl2 is beryllium chloride. Okay. All right, so let's look at these. I think I have to move my mouse. There we go. What type of element is always listed first? We'll look in the box. The first element is always a metal. What type of element is always listed second? For binary ionic compounds, it's going to be a non-metal. For what we're learning today, that might be a polyatomic ion instead of a non-metal. It'll take the place of the non-metal. Still has a minus charge, right? Oxygen has a -2 charge. Carbonate also has a -2 charge. So whether it's a non-metal like oxygen or a polyatomic ion, it doesn't really matter. So it could be either. Is the name of the first element in the compound different than its name on the periodic table? Potassium, sodium, barium, sodium, zinc, beryllium. So the answer to that is no. It's the same. Is the name of the second element in the compound different than its name? So this is iodide, which is the iodine or iodine on the periodic table. This is sulfide. Well, it's called sulfur on the periodic table. So the answer to that is yes. What is the common ending for all names? IDE. In sodium sulfide, there are 2 sodium atoms in the formula. Is this shown in the name? No. We do not need to show the number because we know exactly what the number has to be by deduction. We know that they have to cancel out. So there's no point in indicating the number of each ion in the formula. Right. Again, so if I put calcium sulfate, CaSO4, I have 1 calcium and 1 sulfate, but when I name that, it's just calcium sulfate. I don't have to indicate how many of either is there. I just write the name. What is the charge of the sodium ion? Sodium is always a +1, just like hydrogen. What is the charge on the sulfide ion or the sulfur ion? It's a -2, just like oxygen. Why do you need 2 sodium ions for every sulfide ion? Well, sodium is a +1. Oops. Sodium is a +1. Sulfide is a -2. All right, and so if I look at it now, if I have 1 of each, that's a +1 and a -2. That's not equal and opposite charge. I need another sodium. 2 sodiums will give me a +2. That gives me a -2. Now I have equal and opposite charge. So we need to balance the charge. We have to balance the charge. All right, now let's name each ionic compound that we did not cross out in question 1. All right, so we did not cross that one out, that one, and that one. So that is sodium chloride. That's that one. Calcium chloride is the next one. And this is going to be bigger than what I can fit on the page. The next one is lithium oxide. That's that one. And then magnesium oxide, which is that one. And that is it for this one, right? Ionic compounds. Let's see, maybe not. Let's see. Oh, we've got a little bit more here. Let's name these guys here. So we're going to name these guys here. This is potassium bromide. This is magnesium chloride. This is lithium oxide. We just did that one. Okay, so there's those. Let's do the bottom ones. Now let's do the formulas. Potassium iodide. All right, let's look at potassium iodide. Potassium is a group 1 metal, so it's a +1. Iodine is a -1, so I have equal and opposite charge as is, so I just put them together. Ki is the formula. Boom. Now the next one, magnesium oxide. Magnesium is a +2 because it is in group 2. Oxygen is in group 6, so it's a -2. Equal and opposite charge, just write the formula. MgO. Just put it together. Now let's look at this one, calcium chloride. Calcium is a +2. Chlorine is a -1, so I can't just write CaCl. If I did, look at the charges. They're not equal. I got a +2 and I got a -1. They're not equal and opposite charge. So if I have a +2, I better have a -2. So I'm going to put a 2 there. CaCl2. And that is it, guys. Y'all have a great one. Thank y'all.